All right, time for some exponential functions. Coach Ramsey's over here. He's invisible today. He drank something he probably shouldn't have. So yeah, he's over there. He's right there. You not see him? There's like a shadow. It's that blue. All right. Exponential functions are written in the form of a b to the x power. Different from linear because linear is mx plus b. You have some number multiplying x. Here, an exponential, x is an exponent. So that's your easy way to see if it's an exponential function. X is the exponent. So quickly we'll go over this. A is your y-intercept, or beginning amount, and b is the factor, or whatever we're multiplying by. We can make it smaller, larger, whichever way, depending on the size of the number. That's it. First thing I want us to look at is comparing tables. One of these is linear, one of these is exponential. And I've got some definitions here. Exponential grows or decays by a constant factor, so what we multiply by, for a unit interval relative to another. What that means is this goes up 1. That's your unit interval. Here it's going up 1. So as this does 1, is this doing the same thing down here? And this is kind of the same words, it changes at a constant rate. Here you got a factor, here you got a constant rate. So we're adding 4, adding 4, adding 4. Okay, since we're adding, subtracting the same amount, that's linear. So this is a linear example. So here, if we're thinking linear, because that's what you've done pretty much your whole life till now, plus 8 plus 40 and plus 200. That is not the same. That's not constant. It's not the same amount. So that tells me I need to do something else with these numbers besides subtract them. So instead of doing y2 minus y1, we'll change a little bit. We're going to go y2 divided by y1. So 10 divided by 2 is 5. So from here to here, we multiplied by 5. Y2 minus y1, again we multiplied by 5. So this has a factor of 5. So that means it's exponential, and we'd write it in that form, a b to the x power. Alright, here's the table. We're going to try and write the function from it. So I need to know the y-intercepts. It's not up there. So I need to get this up here to be a 0 for x to have the y-intercept. Well, in order to do that, I've got to find the pattern. So that went down a fractional amount, down some more. Looks like that's a lot bigger. Doesn't look like it's subtracting the same number. So I'm going to divide them first. So y2 divided by y1. Well, if I have 2 sevenths, I cut that in half, I have 1 seventh. So that's really 1 seventh as a factor. Take this, divide it by that. 2 49ths divided by 2 sevenths. Flip it and multiply. The 2's disappear. 7 over 49 is really 1 seventh. So 1 seventh is our factor. So we know it's y equals something times 1 seventh to the x. Now to work backwards. So going this way, I multiply by 1 seventh. So to work backwards, I would divide by 1 seventh. So 2 divided by 1 seventh is like multiply, flip. We should get 14. So y is equal to 14 times y, or 1 to the 7th, 1 seventh to the x power. So here's a little trickier one. You can try it. Should be able to see it down there. So, y2 divided by y1, 0, 0, 0, 2, 1 over 0, 0, 0, 4, 2. That looks to be 1/2 if I simplify it. So the factor is 1/2 or 0.5. I'm going to use a decimal this time because we have decimals. So we have the factor, so we can work backwards. And again, if you ever want to work ahead of me, just hit pause and just try it before I finish. So I need to go backwards a whole bunch of times. Oh boy, I don't really want to do that. So one thing you can do, instead of dividing it 20 different times, we can say we need to get to 0. So from here to here, that's 20 times. So we're going to take that number, 0.00042. We're going to divide it by the half, 0.5. But we're not going to do it just once. We need to do it 20 times to go from here to here. So I'm going to use a little exponent of 20 up there. So that's the shortcut to get from here to 0 real quick. So type that in your calculator, you'll get a number, should be a whole number of some kind. Plug it in for your A, done. Writing the function from a graph. Woohoo! Y-intercept. Very quickly. Got that number. So we're halfway done. Y equals -1 times something to the x power. If you can't see it, let's make these points into a table. So at 0, we're at -1. Then at 1 here, we're at -3. I recognize this graph is exponential, so I don't have to wonder if it's linear or not. So -3 divided by -1 is 3. Now you've written the function. Okay, here, this is more for word problems when you're given percents. It's essentially the same thing. You have your y-intercepts right there, the a value. But we have a 1 plus an r, 1 minus an r. So what that r is representing is some kind of percent rate that we're either gaining or losing. We're either growing or we're going down. So this number would be like 1 plus 0.07, which really means we're gaining an extra 7%. This comes from 1 minus something, which is 0.05. So this looks like we're losing 5%. So down here at the bottom, if it decreases by 12%, what's our factor going to be? Well, it's 1 minus 12% as a number, which is 0.88. Same thing with this. If it's increasing by 10%, we'd use the growth. So 1 plus 1/10 or 10%. So our factor would be 1.1. So we're going to use this more for word problems than a table or graph, because once in a table, when you divide it, that is the number. There's no need for a 1 plus or 1 minus. That's what we're multiplying by. Here, in a word problem situation, they're going to tell us how much it's increasing using percents. So, pause it, read it. I'm going to go ahead and answer it. What is the number of people at the fair after 5 years? Well, I tell you that H is the number of years. That's a typo. Jared did that. He just hit me. You seen it. So plug in 5 up there in our calculator. 4 to the 5th power. Whatever this number is how many people it'll be. So I'm actually asking you just to evaluate the function and plug in a number. Okay, again, pause, answer it. What percent does it increase? So I'm telling you it increases. I'm not even making you wonder. So how much above 100 is that? That's actually 107%, which is an extra 7%. When it's saying how much did you increase or decrease, it's how far above 100 it is or how far below 100 it is. Okay, write the function. That's our starting amount, 40,000 people. It's decreasing, so I'm going to use the 1 minus. So change that to a number we can use, not a percent. Oh, X is wrong. Yep, you caught it. Thanks, Jared. Thank you for telling me that. It should be a T because we're using be a T. There's your function. If we want to know in 2030 how many people, well, that's 29 years. So if they ask me 2030, what's the population, I'd put a 29 there for T. That's just how I could switch it up on you, ask you different things. Okay, pause. You've already read it. Here we go. Okay, this tells me it's definitely decreasing because the factor is smaller than 1. If it's less than 1, it's decreasing. So we're definitely decreasing. So how much did we lose? Well, this is actually representing 79.5%. So that's what we're keeping. That's what we get each time. So how far from 100 is this? Well, we can subtract it. And we get 20.5%. So we have lost 20.5%. Okay, next one here. Okay, hopefully in your head you can tell me what's going on in this situation. We have this much money in our account, and it is increasing, because that's 109%, so we're increasing 9% each year. That's yearly, so we get 9% per year. Another graph or table. I've already written the points here. We know our y-intercept is 2. What's it doing? It's growing, so we can divide y2 divided by y1. We're multiplying by 2. Okay. Again, what is the growth factor? Here, I just want to know what's the factor. You got to know what that word means. The factor is what you multiply by. So, all I really have to do is divide. So, right off the bat, you see 2 whole numbers here. And I'm trying to trick you. Because most of you would think, oh, 12 divided by 4 is 3. The answer's 3. No, it's not. Remember, y2 divided by y1. If the answer is 3, this should be getting bigger. It's clearly getting smaller. So my only option, that's a whole number, that's bigger. That's too big, that'd make things grow a lot. 1/3 or 4/3? Well, 4/3 is bigger than 1, that's a growth factor. I didn't even have to do math to answer this one. But if I did, it would be 4 divided by 12, which simplifies to 1/3. Okay, you've had time to read it. I'm sure you didn't hit pause, so here we go. Beginning amount. There are this many cats. And then something's happening to them here. So it says they are decreasing. So that's going to be 1 minus. 6.3% should be 0.063 as a number. And then that's it. It says write a function. I did it again. I did something I do every time. It's not X, it's W. Most of your tests, that's not even going to matter because they're multiple choice. And I wouldn't take that off on mine. So, here we go. All right, read this one. You've read it. Here we go. All right, so which statements are true? So I'm going to highlight some stuff here. They said it's in this form, so exponential. So they're saying the value of A is 1200. So since I'm looking for true statements, I'm going to see here. At 1, it's 1200. So that's not an A value. That's not the intercept. I need to work backwards to get to my A value because it's when X is 0. So right off the bat, anything that says A is 1200 is wrong. The other ones say A is 1200? Yeah, right here. So now, these two are left. They're saying A is 2000. Well, something has to be true, so I assume that's right. But let's find the factor. So y2 divided by y1 divided by 1200, and we get 0.6. Does 0.6 make sense? Because that's a decay factor. So is this going down? Okay, good check. So that's right. So B must be correct. So if A is 2000, the value of C is n. So C is right here. It's the exponent. And n. N is the number of years. Well, this is happening every year. So, yeah, I could put n right there. It'd still be true. So C is correct. Okay, here's another one. Yay, we've read it. Woohoo. Nice to see you back again after you've read that. Your eyes are going back to normal. Alright, so then find the number of landline customers in 2003. So that's after 1 year. You can subtract the product of this, 10%, and the number of landlines in the beginning. So that means 10% of the beginning amount. We can subtract that from the beginning amount. So 10% from the beginning amount. Is that what this is talking about? Decreasing 10% per year. And we started in 2002, so that's true. So to get the next year, we can do that. Find the number of landline customers in 2003, the next year. You can multiply the landline by 0.9. Well, if we go 1 minus 1/10, we get 9/10, so yes, that one's correct as well. You'll notice the bottom two are very similar. They're asking the same question. So one of them has an error. So we want to know in 2004, which is when x is 2, can we subtract this, the product of that, so 20% of the first year from the first year. So I don't think we're losing just 20% of the first year. That doesn't sound right. Let's look at the last one. You can multiply the landline customers in the first year by 0.81. Well, if this is what it is after 1 year, if I put a 2 there, that's actually the factor 0.81. So this would give me a value. Here I'm subtracting 20%, which is not what we're doing. That would be true if it was like a constant rate, but it's not. Take 20% of the first year, it's not the same thing as taking 10% of that first year and then 10% of that new number, because it's 10% after each year. So C's wrong. Next. Alright, you've had time to check it. Answer is D, because they're saying it's exponential rate. The only thing you do with these values in a table is divide them. So their ratios should be the same. Okay, you've had time to read it. So I'm going to write something up here to see it better. M, N. So which is true? They're comparing rates. Who's greater at the beginning? Well, that would be N is greater at the beginning because its y-intercept's higher. So N is greater until, well, does that make sense? Is this one growing faster? You're growing 80%, you're growing 65%. So M eventually will pass it. Since these are the only two using numbers, I don't really have to verify the number because it's the same in both of them. Our answer is 4. Pause, play, here we go. This one takes a little bit of work. So let's just eliminate some answers. Increasing increasing. So the rate of painting increases, decreases. Wrong. Grows, decays. Wrong. So this comes back to one of the first slides I show you. Is it linear or is it exponential? And in this case, you're just deciding which is better. So I'm just going to show you one of them so we can decide which it is. Here we went up, not quite 200, 192. If we're thinking linear, here we went up 162. That doesn't seem to be very consistent. And here we went up 215. So that's not too consistent what we're adding. So that doesn't seem to be linear. So now if we divide them, we'll see if we get a more consistent number. So again, 742 divided by 550, we get 1.35. So if I divide them, I get 1.35. Divide these, so we're going to go 904 divided by 742. 1.21 is a factor. 119 divided by 904. 1.23. This seems to be a little more consistent. So that tells me this is exponentially growing, some kind of percent, and we're just having to round it because it's money. So they're definitely exponential. So now one of those has the wording of something exponential, as the other one doesn't. So remember those words, constant rate. Here we have constant percent rate. Well, only one of those deals with percents, so that would be C. Okay, you're finding the true statements. Good job, you read all those that quick. So let's just eliminate them. Population was 92 million in 2080. No, it's 16.8 million. Wrong. 16.8 million. True. Population has been increasing. No, it's not increasing. Population has changed by 92%. That one tricks people. This represents 92%, but we actually are losing 8%. It's an 8% change. Okay, that's what we're losing. So that one's not correct. The population is decreasing 92%. Again, same kind of wording, trying to trick you. That is false. It's decreasing 8. The population is decreasing 0.08%. Trying to trick you here. That is not correct. It's the 8%, not that number we subtract from 1. The population in 2085 would be 11.07 million. So to answer that, this was the starting year. That's what I'm asking. We're going to plug a 5 in for T, and then we'll find out that is correct. They just rounded it. And 125 years, there will be no people left. So we can plug in 125, and there will be some people still alive. So there are your two answers. It's just a quick review of exponential functions. Trying to get a little wordy, see how you do on everything.